Okay, today we are going to do section 6.2 and 6.3. We're going to start with section 6.2 and we're going to learn how to add and subtract fractions. So for number 1, 5/8 plus 2/8. All right. First of all, when we're adding and subtracting fractions, we can only add and subtract them if they are like fractions. Two fractions are like if they have the same denominator. So in this case, we see they both are 8ths, which means they're both the same type of fraction. So we can add them together. When we add and subtract like fractions, we only add the numerators and the denominator will stay the same. The denominator is just telling us what kind of pieces they are. So the numerator is going to be 5 plus 2, and the denominator is 8. 5 plus 2 is 7, and the denominator stays 8. So 5/8 plus 2/8 becomes 7/8. 7/8 is already in simplest form, so I'm going to circle that. We are done. Number 2, 4/10 plus 2/10. Again, I notice they are both like fractions. They're both tenths. They're same kind, so I can add them together. And you don't necessarily have to write this middle step. I just did it the first time to show you. So 4 plus 2 is 6. That's my numerator. 10 stays the same. We are not going to do 10 times 10. That would make a whole new type of fraction. They're still tenths. We're just saying how many tenths we have. Now, 6/10 is the correct answer, but we're not done until our answers are in simplest form. So 6 and 10 can both be divided by 2. 6 divided by 2 is 3, and 10 divided by 2 is 5. Now 3/5 is in simplest form, so now I can circle that as my final answer. So always make sure your answer is in simplest form. Although this is the right answer, we're looking for it in this form. Number 3, 3/5 plus 1/5 plus 2/5. Again, I notice they're all fifths, they're all like, but this time I have 3 fractions, but I'm going to do the same thing. All you do is add the numerators and keep the denominator the same. 3 plus 1 plus 2. 3 plus 1 is 4. 4 plus 2 is 6. Okay, 6/5 is the right answer. Now notice it is an improper fraction, and that is okay to have as long as the numerator and denominator are in simplest form, which they are. Now if I asked you to write this as a mixed number, we would do 6 divided by 5. 5 will go into 6 once. 6 minus 5 is 1. Start at the top and go around the clock. So we could also write this as 1 and 1/5. Okay, so 6/5 is the same as 1 and 1/5. This is a step you would take if the directions say to write your answer as a mixed number. Okay, now let's do some subtraction ones with like fractions. Number 4, 19/20 minus 4/20. Okay, I notice they're both like, so I can just subtract the numerator. So I'm going to bring 20 over as my denominator. 19 minus 4 is 15. 15/20 is the right answer, but it's not in simplest form because these both can be divided by 5. 15 divided by 5 is 3. 20 divided by 5 is 4. So my answer in simplest form is 3/4. Number 5, 11/13 minus 3/13. Again, I have like fractions, so my denominator will stay 13. 11 minus 3 is what? 8. 8/13. Is 8/13 in simplest form? Yes, it is. There's no other number that 8 and 13 can both be divided by except the number 1. So 8/13 is our answer in simplest form. All right, now we're going to move on to, we're going to keep adding and subtracting. We're going to keep adding and subtracting, but this time we're going to have unlike fractions. Make sure, number 1, 4/5 minus 3/10. So we're going to mix in adding and subtracting because whether you're adding or subtracting, the process is the same. You just got to pay attention to what sign you're doing. So on all the previous ones we did, they all had the same denominator and we could just add or subtract the numerators. Well, of course, that's not always how it's going to be. So in this case, we have fifths and tenths. Those are unlike because they're not the same. So what we need to do is make them the same. Now, we can't just magically make them the same number. It has to be true mathematically. So we have to find equivalent fractions. But the first thing we do is I circle my denominators, 5 and 10. We need to find the LCM of 5 and 10. Now, some of these very small numbers, last time we talked about how to find the LCM, and there was, a longer process to do that with the really big numbers, but with these really small numbers, we shouldn't have to do that. Meaning, remember that multiples are counting by a number. So multiples of 5 are 5, 10, 15. Multiples of 10 are 10, 20, 30. So if I made a quick list, counting by 5s, counting by 10s, the least common multiple is the first number they have in common. So their LCM is 10. And since this is going to be in the denominator spot, we call 10 the LCD, which stands for least common denominator. So the LCD is 10. Now what I'm going to do with that is I'm going to use that as my new denominator. And when you see problems written horizontally, it's fine when they're like fractions, but a better way and a way I like to do it when they are unlike is I stack them vertically, and it looks kind of weird at first. Make sure you write the right sign, minus. Now, LCD of 10 is going to be my new denominator, so we can write equivalent fractions over 10. 3/10 is already tenths, so I'm just going to bring that over. It's not going to change. But what I need to do is change 4/5 into tenths. So that way over here, they'll both be in tenths, and I can subtract them. So we simply do this by looking at equivalent fractions and how we can multiply across. So 5 times what is 10? 2. So I'm going to put times 2. Now for a fraction to be true, we have to do the same thing to the top and the bottom. So if times 2 down here is true, then I have to do times 2 to the numerator. 4 times 2 is 8. Okay, so 4/5, I want to make sure you know, is the same thing as 8/10. These are equivalent. But for this problem, I want to use 8/10 so that I can do the math so that they'll be like fractions. Okay? So our new problem now, and you don't have to rewrite it horizontally. You can just do it from over there if you want. Our new problem is 8/10 minus 3/10, and now that they're like, bring the 10 over, and 8 minus 3 is 5. 5/10 is the answer, but it is not in simplest form. That simplifies to half. 5 is half of 10. Or we could have divided them both by 5, gotten half that way. But anytime you see the numerator half of the denominator, that will always be simplified to half, like 4/8, 6/12, 9/18, stuff like that. Let's do another one. Number 2. Now we have 5/9 plus 3/4. And I went ahead and wrote them, I should put the plus down lower. I went ahead and wrote them vertically so I don't have to rewrite it again. 5/9 plus 3/4. So first of all, I look at my denominators. I see that I have a 9 and a 4. Those are not like. That's like apples and oranges. So first, I need to find a denominator that I can use for both of them to make equivalent fractions. So we're going to find the least common multiple of 4 and 9. Now sometimes, like on this first one, sometimes your least common multiple will be one of the numbers. Like in this case, it just happened to be 10. In this case, 9 is not a multiple of 4, so 9 is not going to be our denominator. So what we can do really quick is make a list. Count by 9s, 9, 18, 27, 36, 45. You can just make about 4 or 5. Counting by 4s, 4, 8, 12, 16, 20, 24. Do you see anything in common yet? No, we gotta keep going. 28, 32, I'm running out of room. 36, there it is. So I'm gonna circle 36. Now, if you're very strong with your multiplication facts, you don't necessarily need to make a list because you may just in your head already know that the first number they have in common is 36. Some people are very visual and they need to make a list like that. Either way, it does not matter. But 36 is going to be our LCD, the least common denominator. Now, obviously, we've talked about before, they would have more numbers in common going to the right, but we want to pick the least one, so we can work with smaller numbers, and 2, the potential for it to already be in simplest form most of the time will be true if it's the least common denominator. So what we're going to do now is set up equivalent fractions with a new denominator of 36. Okay, we set it up like this, 36 on the bottom, put a fraction bar with a blank on the top, and we're going to use multiplication to find that missing numerator. 4 times what is 36? 9. So we have to do 3 times 9, which is 18. So 3/4 is the same as 18/36. Now let's do it up here. 9 times 4 gives me 36. So up here I have to do 5 times 4, which is 20. So 5/9 is the same thing as 20/36, but now I can add these two together because they are like. So just make sure you're paying attention to what sign you're doing. In this case, we're adding 20 plus 18. I'm just gonna put an equal sign here. 20 plus 18 is 38, and we remember that we don't ever add the denominators, that just comes down. So we got 38/36. Now, that is an improper fraction, and like I said before, that is okay. The problem with this one is that even though it's improper, it's still not in simplest form because they can both be divided. So, what can they both be divided by? I know they can at least be divided by 2 because they're both even. 38 divided by 2 is what? I'm having a moment. 36 divided by 2 is 18. 38 divided by 2 then has to be 19. Okay, so we get 19, I didn't have my calculator at the moment. We have 19/18. Okay, now it's still improper, but this time it is in simplest form because there's nothing else these two can be divided by except 1. So you can go ahead and leave that as your answer because there's nothing wrong with it. You only need to change it to a mixed number if the directions specifically say to do that, but we can just leave it improper. Okay, let's do one more of these to practice. So this time we have 7/8 minus 5/6. 7/8 minus 5/6, and I went ahead and stacked them vertically. Okay, I notice that they're unlike because I have an 8 and I have a 6. Can you think, before making a list, of what is the first number they have in common if we listed their multiples? Can you think of it? You may already know the answer, but I'm going to show you really quick. Counting by 8s, 8, 16, 24, 32. And sometimes when you make the first one, you may say, oh, 24, I know that's a factor of 6, or a multiple of 6, I'm sorry. 6, 12, 18, 24, there it is. 24 is going to be our LCD, which stands for least common denominator. So I'm going to set up equivalent fractions now with a new denominator of 24. Okay, we're going to check multiplication to see what the numerator will be. 6 times 4 is 24, so I have to do 5 times 4, which is 20. 5/6 is the same thing as 20/24. Up here, 8 times 3 is 24, so I have to do 7 times 3, which is 21. So 7/8 is the same thing as 21/24. Now I can subtract these. 21 minus 20 is what? It's 1. What's my denominator going to be? It's going to stay 24. 1/24 is in simplest form. Anytime you have 1 as your numerator, it can't get any simpler than that. You can't get any simpler than 1 of something. Okay? So we got 1/24. All right, so that was adding and subtracting like and unlike fractions. And the last thing we're going to do now, we're going to go on to section 6.3, which is multiply and divide fractions. So we've added and subtracted. Now we are going to multiply and divide. So we're going to start with multiplication. Number 1, 1/9 times 2/3. Do you remember how to multiply fractions? So when we're multiplying fractions, all we simply have to do is multiply the numerators and multiply the denominators. Okay? And this is where some people get confused. You know, when we did adding and subtracting, we don't touch the denominators. They stay the same. But with multiplying and dividing, you will multiply the denominator. So if we multiply the top, 1 times 2 is 2. On the bottom, 9 times 3 is 27. And as always, we have to make sure it's in simplest form. 2/27 is in simplest form, so I'm going to circle that as my final answer. What about something like this? In parentheses, 1/4 to the 3rd power. Now we've learned about exponents, so the 3 is telling the 1/4 to repeat itself 3 times by multiplication. So I'm going to write that as 1/4 times 1/4 times 1/4. Okay, and we're going to do the same thing, but all we have to do is multiply all the numerators and multiply all the denominators. So on the top, 1 times 1 times 1 still gives me 1. And down here, 4 times 4 is 16. Bring down this 4. And 16 times 4 is what? I'm having a moment. I don't have my calculator. 64. Okay, it's 64. So 64 is our denominator. And again, 1/64 is in simplest form because 1 is as simple as you can get. Okay, now on the next two, I'm going to show you another way. Actually, I'm going to do it 2 ways. Show you 2 different ways how you can multiply something. So if we have 1/4 times 8/9. Now the first way I showed you, that always works, that never fails. You can always just multiply the numerator and multiply the denominator. Okay, so I'm going to do it that way first. 1 times 8 is 8. 4 times 9 is 36. Okay, we got 836, which is the correct answer, but it needs to be simplified. They both can be divided by 4, which becomes 2/9. Now that's in simplest form, that's my answer. Now I'm going to show you another way we could approach this, which is especially helpful when you get really big numbers. So in this version, we multiplied it and then we simplified it. Another thing we can do is simplify the fractions first, then multiply what we have left. So we look at the numbers across from each other, so the 4 and the 8. 4 and 8 can both be divided by 4. 4 divided by 4 is 1, so I mark that out and put a 1. 8 divided by 4 is 2, so I mark that out and put a 2. Now if I look at 1 and 9, since the 1 is there, we can't cancel anything out. So we're going to multiply what we have left. 1 times 2 is 2. 1 times 9 is 9. Okay, did I still get 2/9? Yes. Now which method you prefer is totally up to you, because no matter what you do, you'll get the same answer. But like I said, you'll see like on number 4 where the second method can be beneficial. So number 4, if we have 5/9 times 18/15. Now you can use a calculator in this class, so you could multiply the numerators and denominators, but you're going to get some really big numbers, and then the problem with that is you have to simplify it, which is not impossible to do, it's just not the easiest thing to do. So what I prefer to do, especially with bigger numbers, is do the simplifying method first. So meaning I look across, 5 and 15 can both be divided by 5. 5 divided by 5 is 1. 15 divided by 5 is 3. Then I look at the other pair. Sometimes they can both be simplified, sometimes they can't. In this case, they both can. Both sets, I mean. So 9 and 18 can both be divided by 9. 9 divided by 9 is 1. 18 divided by 9 is 2. And so here are the numbers I have, 1 and 2 and 1 and 3. Those are way easier to multiply, and then I'm going to be done. 1 times 2 is 2. 1 times 3 is 3. And my answer is 2/3. That's in simplest form, so I'm done. Okay, so again, you can use whatever method you want. This one's just more beneficial with bigger numbers, so you don't have to do the big simplifying at the end. All right, the last thing we're going to do is some division. Let me grab another piece of paper. So the good news with division is we're going to do the same thing we did with multiplication, except we have to do one step first. So, make sure that's showing. Okay, so if we have 3/5 divided by 4/7. Okay, we have 3/5 divided by 4/7. That is just fine. But what we're actually going to do when you're dividing fractions, we're going to change it into a multiplication problem. Well, we can't just magically change this to multiplication. There's a process we have to do. We're going to multiply the first fraction by the reciprocal of this number. A reciprocal is simply the number flipped. So instead of being 4/7, it's going to be 7/4. And a quick way I remember this is a little saying I call keep, change, flip. And this is only for dividing. You only do this for dividing, okay? And this means we're going to keep the first fraction 3/5, change division to multiplication, flip the second fraction to 7/4. And so now we've changed it into a multiplication problem, which we've already learned how to do, and now we'll just go on from here. Now notice on this one, I can't simplify 3 and 4, I can't simplify 7 and 5, so on this one my only choice is to multiply across the top and the bottom. 3 times 7 is 21, 5 times 4 is 20, 21/20 is an improper fraction, that's okay, but it is in simplest form, so I can leave it like that. I am done, unless it specifically says to change it to a mixed number. Number 2, 4/8 divided by 3/16. Okay, remember whenever you see division sign, we need to do keep, change, flip every time. So we're gonna keep 4/8, change division to multiplication, and we're gonna flip 3/16 to 16/3. Now I wrote it this way just to save paper down here. You can write it below like we did up there if you want. So here I could do 4 times 16, I could do 8 times 3, not terrible numbers, but I'm gonna simplify first. 4 and 3 cannot be simplified, but 16 and 8 can both be divided by 8. 8 divided by 8 is 1, 16 divided by 8 is 2. Multiply what you have left on the top. 4 times 2 is 8. On the bottom, 1 times 3 is 3. Okay, 8/3 is improper, which is fine, as long as the two numbers are in simplest form. 8 and 3 are in simplest form. There's nothing else I can do, so I'm going to circle that. We don't need to change it to a mixed number. Okay, what about when we have something like this? 6/7 divided by the number 12. A fraction divided by a whole number. Well, what we can do is write this whole number as a fraction. Do you know how we do that? If we have the number 12, if I wanted to write it as a fraction, I simply am going to put it over the number 1. Because what is 12 divided by 1? It is 12, and fractions are just division, numerator divided by denominator. So anytime you have a whole number and you want to write it as a fraction, all you have to do is put it over 1. So now I have 6/7 divided by 12 over 1. I'm going to do keep, change, flip. 6/7 times 1 over 12. Okay, so I could do 6 times 1, 7 times 12, but I prefer to simplify it first. 12 and 6 can both be divided by 6, so that becomes 1. 12 divided by 6 is 2. And then all I have left is 1 times 1 is 1. 7 times 2 is 14. 1/14 is in simplest form. Okay, last one. What if we have another situation with a whole number, but this time we have 3 divided by 6/11. Well, 3 is a whole number. Again, if I want to write it as a fraction, I can put it over the number 1. So we're going to keep 3 over 1, change division to multiplication, flip 6/11 to 11/6. Okay. All right, I'm going to simplify the 3 and the 6. 3 and 6 can both be divided by 3. 3 divided by 3 is 1, and 6 divided by 3 is 2. Multiply what you have left. 1 times 11 is 11. 1 times 2 is 2. I got 11 halves, which is an improper fraction, but 11 and 2 cannot be simplified. But just for practice, let's change it to a mixed number. 11 divided by 2. You're always going to do numerator divided by denominator. 2 goes into 11 5 times. 5 times 2 is 10. 11 minus 10 is 1. Start at the top and go around the clock. So we got 5 and 1/2. So again, either of these answers are acceptable, 11 halves or 5 1/2. You only need to take it down here if the directions tell you to. So that is how you divide fractions.